Okay guys, really quick video here on how to use elementary matrices to find the inverse of another matrix, okay? So we're going to start off by defining what is an elementary matrix. And an elementary matrix is a matrix that has one operation done to the identity matrix. Keep in mind that an elementary matrix always has to be square. So let's start off with, we're going to do a quick example. Let's start off with a really easy one, like the matrix of 4, 2, 1, 0. So let's find all the elementary matrices for this. So we just we put this into the reduced echelon form. So the first step is going to be to swap row 1 with row 2, okay? So then this would look like this. And so your E1, your elementary matrix 1, keep in mind that we're going to write right here, I equals 1, 0, 0, 1. Ignore that. So E1 now, we're just going to swap each of those rows. 0, 1, 1, 0. The next step here, we're going to want to do R2, subtract 4 R1, and this is going to give us 1, 0, 0, 2. So now for E2, this is important. You don't do this row operation to this matrix. You do this row operation to the identity matrix again. So this is now going to look like 1, 0, and we just subtracted 4, so negative 4, 1. Okay? So next step is pretty simple. R2 divided by 2. And that's just going to give you 1, 0, 0, 1. You're in row echelon form. Your final elementary matrix is going to look like 1, 0, 0, 1 half. Okay? I'm going to copy these right now. So yeah, this definition here just kind of highlights what we went over, that an elementary matrix is just obtained by doing one simple row operation to the identity. And always to the identity. You do not do it to this, then to that. So for some reason, I wrote this twice here, but it's important to read it twice. Multiplying a matrix by an elementary matrix on the left is actually logically equivalent to just applying a single row operation. So they're just the same thing. Okay, right here, every matrix is invertible, and the inverse is also an elementary matrix. Not important at the moment, but that is a building block for the future. But this does imply that every elementary matrix is square. So you can write that as square or n by n and m by n, whatever. Even if you have, say, a 4 by 3, your elementary matrix is still going to be square. Now, how do you solve this to get to the inverse? This is why you clicked on the video. You solve it right to left. And if you want to just get to the identity, you include A in there. And what I mean by right to left is you start with your elementary 1 on the left, on the A, but then you expand from right to left. And if you want to find the inverse, which you probably do, you don't include A. A is not included for A1. You just do E1, E2, and so on and so on. So I'm going to show you a quick example. This is why I don't want this. Ignore those minor technical difficulties. But what this looks like is we're going to do E1, E2, E3, like this. So I'll start off. I'll bring you guys through the example. So E2 is actually on the left, right like that. And then E1 is right here. So let's solve this. So we're going to have 1 times 0 plus 0 times 1. That's an easy one. That's 0. Now we have 1 times 1 plus 0 times 0. I like that too. That's just 1. Now we have negative 4 times 0 plus 1 times 1. So that's also kind of nice, actually. Now we have negative 4 times 1 plus 1 times 0, negative 4. So a big mistake right now is if you were to bring this and just put it right there and then multiply it that way. That's what I did for a long time, and I was having some issues. You actually bring it and put it right there. Okay, so now we come down here. We have 1 times 0 is 0, plus 0 times 1 is also 0. Crazy how that works. So now what do we have? We have 1 times 1 plus 0 times negative 4, so you just get 1. Now we have 0 times 0 plus 1/2 times 1. 1/2. Now we have 0 times 1 plus 1/2 times negative 4. So 1/2 times negative 4 equals negative 4 over 2, which equals negative 1/2. Oh, I mean, sorry. Yeah, negative 2. I was looking at my 1/2 I already had. So there you go. You just found the inverse using elementary matrices. I hope this helps. Click the first link in the description if you like this video.